ever stare at a problem that's just so big, so complicated, you have absolutely no idea where to even start? Yeah, we've all been there. Well, it turns out computer scientists have a kind of secret mental model for dealing with exactly that. And here's the kicker. It's not just for coding. Okay, let's dive into this incredibly powerful way of thinking. So seriously, think about it for a second. That massive project at work, that personal goal that just seems miles away, how do you even begin? Well, here's the secret. You don't solve the impossible problem. You change it. You make it possible. And that's exactly what we're going to do today. We're going to build a toolkit that lets you do that. We'll start with how to think like a computer. Then we'll learn to break problems down, find hidden clues with patterns and something called abstraction, and finally, design a concrete plan of attack. All right, first up, thinking like a computer. So what does that even mean? It's not about being a robot, I promise. It's about being really, really strategic in how you approach things. Basically, computational thinking is just a fancy term for a really powerful method. It's all about taking a huge, messy, complicated problem and chopping it up into simple, logical pieces that you can actually wrap your head around and, solve. And the best part? You can use this skill just about anywhere. And this whole method really boils down to 4 key ideas. I like to think of them as the 4 essential tools you're about to add to your problem-solving kit. We're going to unpack every single one, starting with the one that makes any big problem feel a whole lot smaller. All right, tool number 1, decomposition. And honestly, the name kind of gives it away, right? It's all about breaking it down. This is your first move, always. You take that giant, intimidating challenge, and you just start chopping it up into a series of smaller, distinct, and, this is the most important part, achievable steps. It's what turns a giant, scary monster of a problem into a simple, manageable to-do list. Okay, let's make this real. Think about making jerk chicken. Sounds like one thing, right? But it's not. You don't just snap your fingers and have a plate of food. The whole process is broken down. First you gotta work, then you gotta get paid, then you can go buy the chicken, and only after all that do you actually get to season it and cook it. See? Each of those is its own little task. That's decomposition, and we do it all the time without even realizing it. Okay, so once you've broken the problem into pieces, what's next? Well, now we get to our next 2 tools, which are all about digging into those pieces and finding the hidden clues. So you've got all your little pieces laid out. Now, you start looking for patterns. You're asking yourself, hey, do any of these look familiar? Are some of these steps kind of the same? Does this feel like that other problem I solved last year? Finding these little echoes and repetitions is the secret to working smarter, not harder. A perfect example of this, think about the FIFA video games. Every year a new one comes out, right? But the developers don't build a totally new pause menu from scratch every single time. Why would they? The menu is a pattern. They recognize that, they reuse the main code, they make a few small changes, and boom, they've saved themselves a ton of time and energy. Now, while you're looking for those patterns, you're also using our third tool, which is called abstraction. And this one is, well, it's basically the art of ignoring stuff. It's about filtering out all the little details that just don't matter, all the noise, so you can focus on what's absolutely crucial. The car analogy is the perfect way to think about this. To drive a car, you absolutely do not need to be a mechanic, right? You don't need to know how the engine works, or the timing of the fuel injectors, or the pressure of the brake fluid, all of that. It's just noise for the task of driving. Abstraction is realizing that all you really need to care about are the essentials. The steering wheel, the gas, and the brake. It makes something incredibly complex feel simple. And see, when you filter out all that unnecessary detail, what you're left with is the real heart of the problem. You see, the things that change, the variables, the things that stay the same, the constants, the inputs, the outputs. Abstraction helps us draw a really clear box around the exact problem we need to solve. Okay, deep breath. We've broken the problem down, we've analyzed all the pieces. Now it's time for the fun part, our final tool, which is all about creating the actual plan. And this is where it all comes together, in what's called an algorithm. And don't let the word scare you. An algorithm is just a recipe. It's a step-by-step plan. It's the blueprint that you build from everything you've done so far. A blueprint that anyone, or even a computer, can follow to get the right result every single time. And generally, there are 2 really great ways to sketch out this blueprint. You can either write it down, using something called pseudocode, or you can draw it out visually with a flowchart. So here's what pseudocode looks like. Super simple, right? Notice it's not some crazy programming language. It's basically just plain English, laying out the steps in a logical order. You start, you get your inputs, you do a calculation, and you show the result. Anybody can read this and know exactly what to do. And the really cool part? Look at how easily that simple plan turns into actual computer code. This is a program in Python, but you can see the logic is exactly the same as our pseudocode. It just goes to show you, if you have a great plan, the hard part is already done. But hey, maybe writing it all out isn't your style. What if you're more of a visual person? Well, that's where the other method comes into play. Flowcharts let us literally draw our plan. It's a visual language where every shape has a specific meaning. The ovals are for the start and end points. The parallelograms are for inputs and outputs, like getting numbers from the user. Rectangles are for the actions, the doing parts. And the most important one, the diamond, is for making decisions, the yes or no questions. It's a way to actually see your logic laid out. So there you have it. We've just walked through and built a complete 4-part toolkit for thinking your way through pretty much any complex problem you can imagine. So let's put it all together one last time. This is your new computational thinking toolkit. You've got decomposition to smash a big problem into little pieces. You've got pattern recognition to find the shortcuts and similarities. You have abstraction to ignore the noise and focus on what really matters. And finally, you have algorithm design to build that perfect step-by-step plan. So, now I've got a question for you. What's that one impossible problem in your life, at work, in school, wherever, that you're going to go and tackle first? Because now, you've got the toolkit to get started.